Okay, we are going to be constructing the Lewis structure CH3O-. Okay, first off, this equation right here, number of bonds, is going to let us know how many bonds this molecule should contain. The electron demand is how many electrons each atom would like to have to fill its outer shell. Hydrogen likes to have 2 to be like helium. It follows the duet rule. Carbon and oxygen like to have a total of 8 to follow the octet rule to be like neon in this case. So we would have 2 here, 2 here, 2 here, 8 here, 8 here. So that'd be 16, 18, 20, 22. So that's our demand. Let me clean it up first before I start doing that. So 22 minus our supply, which is how many valence electrons each atom will contribute to the molecule. So hydrogen is in group 1, so it will contribute 1 valence. So these 3 contribute 1. Carbon is found in group 14, so that's going to contribute 4. Oxygen is in group 16, so that will contribute 6. So 6 plus 4 is 10, 11, 12, 13. So 22 minus 13, not quite yet, because we have this minus charge. So when we have a minus charge, we're adding that on to our 13. So let me go back and make this a 14, because it'll be 13 plus 1 because of the negative charge. We'll enclose that, and that will be 8. So then we'll do 8 divided by 2, and that will give us 4. So let me get rid of these numbers over here. Oh, it's gonna, there we go. Let's get rid of these numbers so we can make our bonds. Okay. Hydrogen will make single bonds to fill the duet rule, so I always do the single bonds first. So we have 1, 2, 3 bonds, but we want to have 4 bonds, so we can only have 1 left because 1, 2, 3, 4 minus 3 is 1, so we have 1 bond left to give. So let's fill in our lone pairs. So we count these up, 2, 4, 6, 8, 10, 12, 14, which is right there. And then 2, 4, 6, 8, 10, 12, 14. But if you want to find the demand, you just do 2, 4, 6, 8, 2, 4, 6, 8, 2, 2, and 2, which is 22. So everything's good. Let's do the formal charge. Carbon has 4 valence electrons, minus the non-bonding. We have no lone pairs in this case, so it's 0. Plus the number of bonds, we have 4 single bonds, 1, 2, 3, 4. So 4 minus 4 is 0. So it does not have a charge, which is good. Hydrogen has 1 valence electron. It has no lone pairs, so it's 0. Plus 1, because we have 1 bond, a single bond. 1 minus 1 is 0. These hydrogens right here will also be 0 because they're the same thing. In this case, they each have single bonds. So that'll save time. Oxygen is found in group 16, so 6 valence, minus how many lone pairs? We have 1, 2, 3 lone pairs, but 1, 2, 3, 4, 5, 6 total non-bonding electrons. So we put a 6 right there, plus the number of bonds. We have 1 bond, so that's going to give us 6 minus 7, which is -1, which is good. So we'll put our negative charge on the oxygen. And the reason why I say it's good is because we're constructing the CH3O minus. So we need to have that minus, and it's on the most electronegative atom, which is perfect. So this will be our Lewis structure for CH3O minus. Hope this video helped, and thank you for watching.